and welcome to another episode of Curiosity Labs Between Two Nerds, where, as you may well know by now, every week we invite a wonderfully small human being on to have a little chat about science. As ever, if you are watching this on YouTube and you need your eyeballs for something else, you can find us on all the major podcast players. Or if you're listening to us right now and on the podcast and wondering what we look like, check us out on YouTube/Between Two Nerds. If you haven't already, please do hit that subscription button and the little bell if you're on YouTube, and we can let you know when we've got new content. And if you like what you hear so far, probably not, but if you want to already hit that like button, we'd really appreciate it. Also, we've got loads of comments from you guys, so thank you very much for that. We thoroughly enjoy nearly all of them, and we'll try and reply to as many as we can. But if you've got something you want to tell us, if you want to correct us, or if there's something you want to discuss in the future, just leave a comment down below and we will take a look. Now, on to this week's wondrous, tiny human being. We have...
Marwan.
Marwan. How are you, Marwan?
6.
6, cool. And how
Marwan's
are
6
you?
years old.
Are you good?
Yes.
You excited?
Yes.
Let's sit straight.
Sit straight.
Okay.
Don't wobble the chair. School rules apply, basically.
And you know the nerds. I'm Mo.
And I'm Eugene.
Okay, Marwan. What would you like to talk about? Or what's your first question?
Why are popcorn seeds hard and the popcorn you eat is soft?
Okay,
question.
very good question. Okay, because
Have you eaten a hard popcorn seed before?
Yeah.
Where you dig
great.
down to the bottom of the bag and you get the ones that didn't pop?
and you just
It's
haven't
like,
really got your fill, so you're like, man, it's
I'll
all
eat
the
it
same.
anyway.
Yeah. Well, okay, so it kind of has to go with the reason why popcorn pops in the first place. Have you ever made popcorn yourself? No, you haven't put it in the microwave and it goes pop, 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 pop.
No.
Get someone else to do it. It's
No.
much easier.
Or I
Cinema.
guess- yeah, in the cinema. So pop the corn, right? It's just a seed. Inside that seed, so first there's this hard outer bit of the seed, like the shell bit, right? The bit that gets stuck in your teeth,
Yeah.
right? That bit. And then you have this thing, it's called starch. Starch is the same thing like potatoes and old seeds are made out of. It's kind of what gives the seed the energy to grow into a plant, okay? Then inside that, you also have some water. Okay, now what happens to water when you heat it up?
It becomes hot.
True.
Such a good answer. Correct. 100%
Yeah, it
correct.
becomes hot and,
Smoke.
not smoke, it turns into that white gas. You know what we call that gas?
Yeah.
Steam, right? Now here's the thing, so when it's water and it turns into steam, it wants to take up more space, okay? And it starts to expand. Now, it wants to expand, but that hard shell, the bit that gets stuck in your teeth, is holding all of that steam in. And remember, we've done a rocket experiment, right? What happens when there's too much gas inside?
It pops.
It pops, exactly. And the same thing happens here. And when it pops, it opens up. Now, the other bit inside the starch, right? It's like you've pushed lots of this gas into that starch and it makes it all puffy and turns it into that's
Delicious.
popcorn. It's kind of like, have you ever baked a cake? Right?
You baked a cake, but you haven't made your own popcorn. You must.
Right? So when you bake a cake, you put this batter in, gas inside forms because of the baking soda and makes the cake all nice and fluffy now, right? The same thing's happening, but just much quicker and much cooler with popcorn. And that's what makes popcorn.
So all those little pops are little explosions.
Yeah.
So where the pressure's built up, then finally it has to explode. So when you're cooking, or when someone's cooking popcorn for you, have a listen, and all those little pops are explosions that give you that yummy, airy, squishy, semi-delicious
Yeah.
snack. I've got no idea why it's associated with the cinema so much.
I think it's because they grow a lot of corn in America and they try to push that snack. That's why we use corn in so much
You
stuff.
made that up.
No,
Such a good answer.
I think it's I think that's be why, because you're finding more uses.
What do we do with this
for this
stuff?
crop that
Yeah.
you can grow, and that's why high fructose corn syrup's a thing.
Yeah.
Because you're trying to push.
Loads of it.
Because you can grow
quite
so
cheap.
much of it, so what do you do with it?
And you
trying to make
need a snack that lasts. So you get loads, bucket of popcorn.
What I-
Doesn't weigh too much.
What I don't get is why all the movie snacks in the theater are noisy. Who thought of that? Popcorn makes noise. You're trying to not make noise in the cinema, not you, the kids. Oh, kids in the cinema. You can see I'm not a parent, so I haven't had to endure this.
So what's a non-noisy snack?
I don't know, jelly?
Jelly, cheese sandwich,
Yeah, something
Okay.
like that. Or like nachos as well, noisy.
noisy, crisp.
And
yeah,
then when
noisy.
I'm eating it, I'm always so conscious about the amount of noise I'm making. Like, I'm trying to bite softly.
Bite softly.
Or try to eat all of it before the movie actually
Yeah.
starts.
Hold the crisp in your mouth, let it
Yeah.
get moist, and
Moist.
then break it with your tongue. Sorry, Marwan.
What's your favorite cinema snack?
Popcorn.
Popcorn? Yeah, what flavor?
Cheese.
Cheese.
Yeah, they do. When I was a kid, back in the day.
Salt
they-
or nothing else?
Yeah, it was
Yeah.
salt or plain. Now
Yeah,
you
or
got,
butter, then
oh, it's amazing.
caramel now.
You get knickknacks, which is a crisp that break up, cheesy. Good.
But
chat.
I like to mix it, because you want a bit of sweet, bit of salty.
Little surprise
Yeah,
every
Ooh,
time.
What's this?
Sometimes I mix salt and caramel.
Yeah, that's nice.
Ah, yeah, no, I do like the caramel popcorn.
Yeah. Because you just want a few, right?
Yeah.
Like you never know. It's like a party in your mouth.
You always want more, though.
Yeah, right? Okay.
Good science chat, that.
Yeah. Anyway.
What's your favourite cinema snack? Please leave us a comment below.
All right. And another question.
Why does the Earth orbit the sun?
Why does it orbit the sun? So very
Segueing
popcorn
in.
related, right? So why does the Earth orbit the sun? Well, the sun's got this force that's pulling the Earth into it. What's that? What force pulls something towards it? Like the Earth has it as well. It's the reason why we're
Gravity?
Very good.
Exactly. Now the Earth has gravity, but so does the sun. Now, actually, everything, as long as it weighs something, right, has gravity. Okay? So, now the heavier you are, the more gravity you have. Okay? Now the sun's really heavy, right? So that gravity from the sun stops the Earth from flying away into outer space, which would be a very bad thing for us
Yeah, that wouldn't
on
end
Earth, right? So it keeps us kind of in orbit around the sun, right? But then why doesn't the Earth crash into the sun?
Because it goes at the right speed.
Oh, good
Oh,
job.
my
You've been
goodness.
paying attention in class.
Very
Very
good.
good. Yeah, so it has the right speed to stop that from happening. All right, right speed and the right direction. So if that's the sun, the Earth's direction is that way, tangent to the sun. Never mind though. And it has to have the right speed. If it went any faster than that, what do you think would happen?
It will go out of the solar system.
Yeah, so
Absolutely.
exactly. So it'd fly out of orbit and now off into outer space, right? If it was going any slower, what do you think would happen?
The planets might crash into it.
Yes, so the planet might crash into the sun. So it'll slowly start to spiral in and crash into the sun. Okay? Yeah?
Not a
Got that?
bad day for planet Earth.
Another bad day for planet Earth, exactly. Right? Any you had another question about that, I think?
Yeah?
Yeah?
Why does it take a year for the Earth to orbit the sun?
Yeah.
Kind of answered that.
Yeah.
Because if we were going faster, so it takes us a year, us being planet Earth. Do you know can you name the other planets in the solar system?
Mars,
Very good.
Jupiter,
Very good. I'm counting here.
Saturn,
Yeah,
Uranus,
Yeah.
and Neptune.
yeah.
You
Earth.
see, yeah.
Two more. You've got to go the other way.
Closer to the sun.
Mars,
No, the
No.
other way.
It's another M.
What's
one.
the closest to the sun? Do you know? Starts with the M.
Mercury,
Very good.
good.
Oh, there's one more.
The hottest
Let's do the
planet.
set. The.
Venus.
Very good.
Very good. Yeah.
So an Earth year, as you've rightly said, so it takes Earth school rules, 365 days for us to go to do one lap, one orbit of the sun. And that's because the distance we are from the sun, that is the right speed. If we were going any faster, you'd think, well, if we were going a bit faster, our year would be quicker. So it might take us 300 days. But the problem is, we'd just get further and further away and end up shooting off into space. If we were going any slower, you might say the year took 450 days because we slowed down. But if that had happened, as we've just explained,
It would take less time, so it might crash into the sun.
Exactly.
Very good.
So our right speed for the distance and the size of our planet that we are away from the sun happens to take 365 days to do a lap. And we couldn't go any faster and we couldn't go any slower. But the other planets, because they're in a different position in that solar system and they're different sizes, their year will not be 365 days.
It could be less.
It could be less, it could be more. So sometimes it's generally the closer to the sun you are, the faster you'll be moving, and the less distance you will have to do that circumference of your orbit. So we have to go 365 days, otherwise we wouldn't be here, because of what you said at the very beginning, that the reason that we are in a stable orbit is because we're going the right speed. So Jupiter goes its right speed and has a longer year. It takes longer to get around the Earth. So I don't know the answer. Do you know what a Jupiterian?
Jovian.
Jovian, yes, exactly. A Jovian year. No idea. Leave a comment. What's a Jovian year?
I know on Mercury, the day is longer than a year. I think it's about 2 months for Mercury to do an orbit. 2 Earth months, so about 60 days, I think. Or it could be 3 months now. I'm saying this out loud.
Someone will correct us.
Right? But then the day, which is about how Mercury rotates on its axis, right, is actually longer than its year. Which is weird because we're used to the Earth way, but it's not that big a deal. No one's living there, so it's fine.
Don't care.
Yeah, they got bigger problems. They're right next to the sun.
It's really hot there.
Yeah.
Does that make sense?
Yeah.
Yeah, so that's why it has to be 365 days. That speed is very important. Okay.
Is that good?
Okay, another question?
Why does the sun bend space?
Yeah, good. Yes. Now,
That's linked.
yeah. So you're remembering in class once we did the thing with the trampoline, right? I called that stretchy fabric of that trampoline, I called it the fabric of space-time, right? Which is kind of like, so the fabric, so it's kind of like the thing we're in. It's invisible, you can't touch it, but you're in it right now, okay? Got it? I know.
Makes perfect sense.
It requires a little bit of a leap, right? But so space is actually this fabric. Space, we call it space-time because it's space and time forms this fabric. And the important thing about that fabric is that you can bend it and stretch it, okay? Now, the things that bend it are things that have any weight, right? And remember I told you everything has gravity, right? So if you took something really light, right now we are in space-time, and we are bending space-time, but we're bending it a very tiny amount, okay?
I'm bending it a tiny bit more than you.
Right? Then if you take something like the sun's, because it's so heavy, right, is bending it way, way, way more. It's distorting space-time, right? If you go back, imagine that trampoline and how it bends, right? That kind of shape. Okay, like it makes a little well sort of thing. So that bending of space-time is actually what gravity is, okay? So if we put a marble, so if you had like a heavy weight on that trampoline, we put a marble in there, when it gets into that well, right, it gets pulled towards the weight, which is kind of like if I dropped an apple here, it would fall to the earth, right? So that bending of space-time is gravity, there's no reason why the sun bends space-time. It just does, and that's what gives it its gravity. That's what gives everything its gravity.
The amount it bends it.
Yeah.
So if you doubled the size of the sun, Marwan, or doubled the mass of the sun. So if I got a sun twice as heavy, and remember our trampoline, and we replaced our sun with a sun twice the mass, what would happen to that trampoline?
Snap?
It might well do.
Yeah,
yes.
it could, yeah.
So it would bend way more. So our trampoline almost certainly would snap, but you'd need a hole in the floor, and it would go way. So that curve, that bend, would be even steeper and even bigger. So you'd get more gravity. So again, if you were that marble, you're far more likely to fall into it, or you'd need to move much, much faster to maintain an orbit.
Yeah.
Go on.
So if you go a bit fast on Earth, will the Earth crash into the sun?
No, if you went too fast on Earth, or as in if Earth started moving faster. No, so that's where we were before. So if Earth is orbiting and it got faster for some reason, what it's going to do is get further away from the sun. Now, if you're talking about, so if we swapped our sun for a sun twice with twice the mass and left Earth where it was, Earth would no doubt have to move faster to maintain the orbit. So the bigger that sun got, the more mass you had in that sun. For our distance away from that sun, that star, we'd have to move faster and faster because the curve, that bend of space-time, would be even steeper.
Yeah.
Got it?
Yeah.
Good.
That's actually, so if we wanted to leave the solar system, we'd have to kind of move, unless we can keep accelerating, changing our direction thing, we have to move close to those speeds. So the speed to leave the orbit, like even the Earth has things that orbit it, right? Like the moon orbits the Earth, and the satellites up in space, they orbit the Earth, right? So actually, if we wanted to leave the Earth and go off into outer space, right, we would have to move at a very particular speed. So if you had like a gun, right, that could fire bullets that fast, and it's really, really fast, by the way, right? You could fire bullets that quickly. Those bullets wouldn't fall to the Earth. They would leave the Earth as long as they kept that speed.
What if you shoot it in space? Will it crash into the sun?
It depends which way you fire. And okay, so let's say you're in space.
Depends how fast
Well,
you fire.
first of all, the direction. You have to make sure you get the right. If you're firing it at the sun, it's gonna go to the sun, right? If you fired it, let's say sun's here, and we're firing it that way, right?
Yeah.
It depends on the escape velocity, that speed, and that speed changes. The further you are away from the sun, the slower that speed is, right? So at a particular speed, you could fire a bullet, right, at the right speed, and it would leave the solar system, meaning it would escape the sun. But you also have to worry about when it's traveling, it's going to, if there are other planets that happen to be in the way, then their gravity might start to pull it that way and then that way, right? So it's like, it's kind of, you know what, it's like a dance going on in space, right? All these things are moving around, they all have their own gravity, and they all have things dancing around it. So you have to like plan it very carefully. So at NASA, when they're sending things, they've sent things out of our solar system, right? So they had to pick the right, so they have to plan this journey very, very, because once you're in space, you can't really change your direction because that requires a lot more fuel, and fuel is something that is, you know, you don't have a lot of.
There's
right?
no gas stations.
Yeah, exactly. There's nothing to refuel either. I mean, solar panels and stuff.
Yeah.
But no, so they have to plan the right time to launch something so that it gets to where it needs to, and it
The
does.
sun moves.
Yeah, but the sun's moving. The planets are also coming into that path. So, like even with the moon. So let's say we wanted to.
My head's the moon.
So yeah, let's say we're on Earth. That's the moon, right? We want to fire a rocket. Now we don't aim it straight for the moon, right? because that moon's moving. There you go. See, it's moving, right?
There we go.
So
This is me being the moon, Marwan.
Yeah. And then also it takes like 3 days. So it took the rockets that did go to the moon, right? 3 days to reach there. So if we aimed it for the moon, it would actually, we'd miss it because the moon would be somewhere else by then. So you have to fire the rocket to where the moon is going to be in 3 days. So you have to plan all of those things
How
there.
could you tell?
How could you tell? Actually, because of, so these laws, so this is like the law of gravity, right? Discovered by Isaac Newton and made even better by Albert Einstein. And when we write laws in science, we actually write as a mathematical formula. So formula is like 2 + 2 = something. That's, it's not a quiz. I know you'd know that, but yeah. So we kind of write it with math. And you just have to put the right numbers, like how fast you're moving, how heavy something is, right? Acceleration, things like that. And then you'd be able to map where everything is going to be and when it's going to be. So actually they'll have computer programs that are running like simulations, right? That are showing you where everything will be at different times in the future. It's pretty cool.
So it's completely predictable.
Yeah.
So we know, and you can predict it, and you can go way, way, way ahead. You can go forward 1,000 years and predict exactly where the moon's going to be.
Even further.
Well, as far as you like, to be honest.
That's how we know when eclipses are going to happen. We had an eclipse here 2 weeks ago. I saw it.
I didn't.
Yeah, so we had an eclipse, and so we know when the eclipses are going to happen for the next like thousands of years, as far as it cared to calculate. Good question. An eclipse is basically when something in space gets in the way of something else.
Yeah.
Okay, so here on Earth, we can have 2 types of eclipses. We can have a solar eclipse and a lunar eclipse. Okay, a solar eclipse is when, so we have the Earth. So
I'm Earth.
Moon, sun. If you got in the way there, now we have a solar eclipse because anyone
So if
on
you look
Earth.
at here, so if that's you stood on Earth looking at the sun, can I see the sun? Or have I just hit your face, which is the moon? So you are in
the
the
lighting
way.
doesn't help us here, but so it's basically when moon's shadow falls on the Earth because it's in between the Earth and the sun. That's a solar eclipse. So if you're in that shadow when you look up at the sun, which you shouldn't do without the right glasses and everything, right? You would see the moon covering the sun. And if it's a total eclipse where the moon completely covers it, it's really amazing. I've never seen one, total one at least. Then a lunar eclipse is when the moon goes behind the Earth and is in Earth's shadow. So when you look at the moon then, you get a blood moon, where the moon looks red. And you've seen that? Yeah, those are more common. I mean, they don't happen more often, but they're more common to see. Yeah, so those are eclipses, when things get in the way.
How we're lined up.
Blood moon.
You've heard of blood moon?
I never saw one. I only saw a picture.
Yeah, I think I've shown you pictures.
There was one, I think there was one here last year, but the pictures always look better than whatever you saw, unless you're very, very lucky.
Yeah, but you do see kind of, so I think it was it's quite a while ago.
An orangey hue.
Yeah, the moon is always strange colors. Yeah. Yep. Any other questions?
Pressing questions.
No.
No?
Enjoy that? Did
Yeah.
it make some sense?
Yeah.
So we had popcorn and gravity. That's the theme of the podcast. Is that cool?
Yeah.
Yeah?
High five.
Thank you for that, Marwan. You were awesome. Right? And
Thank you very much for watching. We will look forward to your comments down below. I can't remember what questions we asked today, but there were some random ones. Please do hit that subscribe button. Please do hit that like button and the little bell. And if you're listening to us, rate us and star us and favorite us and do all those wonderful things.
reviews or something.
Review us. That's the podcast thing. Do all of those things. Thank you. Thank you very much. Thank you, Marwan.
Thank you, Marwan.
Wanna
Should we
give
wave at the camera?
Big wave. Faster.